So the final video from chapter 9 is going to be on power, which is covered in chapter 9-9 in the textbook. Okay, so power is the rate at which energy is transferred into or out of a system, or you can think of it as the rate at which energy is converted between different forms, so say between kinetic and potential. So we can calculate an average power. So an average power in terms of the work done, it's the work done on the system or work done by the system divided by the time that took, so delta t. So that's the time interval over which this work was done. So, and if we want to think about an instantaneous power, well, as usual, we imagine taking that time interval delta t and taking the limit as delta t goes to 0, so shrinking it to 0. And so that actually defines a derivative. So the instantaneous power is dw, so the derivative of the work with respect to time. Now, if you think about the power dissipated by friction, so remember friction is one of these dissipative forces, and if you want to know the power involved in that, and remember friction, the work done by kinetic friction typically shows up as thermal energy in the system. So the average power dissipated by friction you can calculate as the change in thermal energy of your system, delta E thermal, divided by the time that took, delta T. And again, if we want the instantaneous rate, you take delta T, shrink it to 0, so it becomes a derivative. So the instantaneous power dissipated by friction is the derivative of the thermal energy of the system with respect to time. Now, and just one other thing to mention here, so another sometimes useful way to calculate power, so in terms of the work, well, work, remember, is force times a displacement, dr. So if you do a little algebra, so if work is F dot dr, then, well, you can write this as F dot dr dt, and the dr dt, of course, is just the velocity. So another way to calculate the instantaneous power is force dotted into the velocity.